this is your page 22 bonus problem, and let's see if you can do this. Here we go. This will be on the test as a free response. Okay? This is the bonus, but now it's expected to be something you learn how to do now. So here we go. Okay. So while only 5% of babies have learned to walk by the age of 10 months, and 75% are walking around the age of 13 months, okay, we want to then know, using that information, find the mean and the standard deviation. Okay? I'm going to show this to you two ways. One is kind of a common sense way. I'll do that first, and then the people can get going and working on it. And then I'll show you the mathy way, because if you're just a person who says, give me a formula, I want to plug through the formula, and let's do that, then I'm going to show you that process as well. So the point is, we have two unknown variables. If you have two unknown variables, you really are going to need to have two equations to set up. Okay? So I'm going to draw a picture of what's happening, because that will help you see what's going on. We have 5% of babies walking by the context time, the x value of 10 months. Okay, so that's your context. So I can write an equation from that two pieces of information. The problem is, I need to be able to find the location of this on the normal curve. Where would this 10 months be located on the normal curve such that 5% is below it? Below the 5%. So inverse norm of the area below is the z at that spot. So inverse norm of my 0.05 puts that thing 1.645 standard deviations below the mean. So you have a z-score and you have an x value. You have z and x. You do not have mean and standard deviation. But you could write one equation out with those two variables, and it would look like this. Here's your z equals, what's the x for this location? 10 months minus the unknown mean and the unknown standard deviation. Okay, so there you go, one equation. Now, let's do the other equation. It is based off of the information that says 75% are walking around at the age of 13 months. So, that's going to be, say, maybe about right here. 13 months has 75% of data below it. So 75% of data is below it. How do I find the z-score here? Is inverse norm of the area below, which the area below is 0.75. That comes out to a z-score of 0.6745. Now, people, based on what we just did 10 minutes ago, this should sound familiar. Why does that sound familiar? Because the 75th percentile is quartile 3. Good. So we've seen that z-score somewhere before. But anyway, let me write that equation. So therefore, what would this equation for the new data look like? Okay, very good. So mathematically, here are two equations and two unknowns. In Algebra 1, if you have two unknowns, you have to have two variables to be able to, or two equations to solve. If you had three unknowns, guess how many equations would I need to solve? Yes, 3 equations, and so on. 4 unknowns, you'd need 4 equations, and so on. So here, I can go ahead and do this. You can do substitution or elimination or whatever, but first, let's fix it so with the fraction going on. How are you going to unfractionize it? Okay, how about we multiply both sides by standard deviation to get it off the bottom on both problems. So, I will rewrite these all nice and neat. Here's what you got. Okay. So, there we go. So, I've got myself a couple of equations ready to do good old algebra 1. What process would you like to use to solve that? I see these two means being right there on top of each other and being both just a regular old mean. I see elimination. The problem is that they're both negative, so what you gonna do? Okay. I'm going to multiply this top line by -1 so that I change the signs, and then therefore these guys eliminate. So you can figure out the standard deviation, something like that. I don't know if that's the complete correct sum, but when you do divide, you get a standard deviation of 1.29, and you are really close to being finished.
Is that supposed to be a 7?
That is a that's a -10 or something. Okay. All right, so now I'm going to pick an equation and plug that thing back in to there and get an answer. So 0.6745 times my newly found standard deviation. I'm going to solve with algebra, and you get somewhere around 12.14. 12.13, 12.14, I don't remember. Somewhere around there. So there's your things. Alright, so you then are going to do page 23 in your packet that has two sample systems. It's got the one about Peyton Manning, and then so it's got this one here about Peyton Manning, and then something about quarterly retail sales. Okay, so you're going to work on those two problems to make sure you've got this systems stuff down. Alright, so you're going with that. I want to show you, however, maybe an easier way to think of this, like some common sense stuff going on. So if you are ready to digest some common sense stuff, then listen up. If you think that'll confuse you and you would just rather go with the formulas, then ignore me right now. Okay, so here comes some common sense stuff. It's going to save you about half of this work. Well, here's the first question. If this is 0.6745 standard deviations up, and that is 1.4645 standard deviations down, how many standard deviations is this from the lower z-score to the upper z-score? It's 2.314 standard deviations from here to here. Because, yeah, you're just adding them together. Because this is 1.645 down, and this is 6.745 up. So if I just combine those two distances together, that's what you get. All right. Well, contextually, how much do those two standard deviations span? 3 months. Voila. Boom. There's your standard deviation in like no time at all. I know. I'm going to tell you, I don't know common sense. Somebody else showed this to me, and I was just like, ugh, I hate that. That doesn't come natural to me. But anyway, I wanted to show that to you in case that helps you. And then from there, of course, you do have to have an equation to plug in and go from there. All right, so whichever way you choose, work those two problems about Peyton Manning and the U.S. retail sales now. Let me go ahead and let you check that. Okay, so if you were getting numbers that were a little bit off from me, that's fine. You rounded to something different. So on this bottom one, they were very large numbers. Standard deviation somewhere in the realm of 218,000 with a mean of 1.1 million. Okay, quarterly sales. Okay, so those were large numbers. Now, again, if you go the common sense route, then the distance in the standard deviations, so from one standard deviation to the other standard deviation, you're basically subtracting one from the other, was 0.589 standard deviations. And then over the course of this much context. So there's that, and then you get the standard deviation from that. So either way is fine, as long as you're successful with one of the versions, okay? So now for homework, I want you to do pages, so you should have, sorry, by the way, you should have 23, 24, and 25 completed. And then for homework, I want you to do pages 26 and 27, which are the warm-up, but we still have 10 minutes left, so I'm going to talk to you a little bit about it first. Here we go. Let's take a look at page 26. Okay. So here we go, page 26. This first problem is about students that were taking college classes, and there was data collected on how many hours they were taking that particular semester. So these students were taking an average of 16.65 hours that semester, standard deviation, median, and so on. Okay, so here's the data in terms of how many hours they were taking. Well, this college wants to basically transform this data into money and see what the mean and the median and the standard deviation and all those things are for money. So if you remember our little thing about going through a transformation, if the data that you have goes through a transformation, addition and subtract, addition and subtract, addition and subtract affects the center only. So that says that this plus $35 is only going to change the mean and the median when you plug them in. So for this mean, I would be taking the mean hours and plugging it in and then computing. Now, how about the multiplication? What is multiplication and divide? Multiply and divide, multiply and divide, multiply and divide affects them both, meaning it affects both the center gets multiplied by 73 and the spread gets multiplied by 73. Does the spread get added 35? Does the spread get shifted 35? No. Okay? So that's what that problem's about. Transformation rules. Okay, next. Down here on number 2, you're going to be doing the drawing and labeling like I taught you how to do earlier in the class. And then let's take a look at number 3 on the next page, on page 27. We got Dalmatians. We have female Dalmatians and a female boxer. So we have all this information about Dalmatians and boxers, and we're wanting to compare them to each other. Well, I'm pretty sure Dalmatians are very much different than boxers. Do you agree? So if I have a particular dog and I want to see which one is more underweight, don't you think that means though in relationship to its own breed? Okay. So how can I compare Dalmatians to boxers if they're two totally different breeds? Sorta, yes. Standard deviation says it. How can I compare two different things? Standardize it by making them z-scores. Yeah. So you're going to want to get a z-score for the Dalmatian and a z-score for the boxer, and how would you determine which one is more underweight? Not by percentage. Which one is the farthest below the mean? Which z-score is farthest below the mean? Okay? And then here, number 4, we're pretty much, this one, you are finding a percent. What percent? What do you have to do when you find a percent or a proportion of observations? When you find probability? Let's see. Let me do this song. Yeah. Find probability. Find the proportion of observations. When you find percentage, use norm CDF. So you are not done until you have norm CDF to some z-scores. And look at this. Look at this statement B, or question B. Find the IQR. Well, what did we just do at the beginning of class to enable you to do the IQR? Yep. Find your Q3 and find your Q1 so you can find their difference. Okay? So the warm-up, here's your homework.